All right, welcome back. This is the second part of the videos over 8.1. We looked last time at the 5 logical operators, and, or, not, if then, and if and only if, and the different symbols you can use for each of them. In this part, we're going to look at the basic meaning of each of those 5 operators. And we're going to look at that using something called a truth table. There's going to be 5 truth tables, one for each operator. So here we go. We start with a question, we'll start with P and Q. Remember that dot means and, P and Q. And we're going to be asking, when is this true and when is it false? Because it's a statement, and every statement is either true and or false. So we're going to be asking, when is P and Q going to be true? When is it going to be false? That's the big question we have in this section. So let's take a specific example. Let's suppose that P is today is Wednesday. Let's suppose that Q is we will have class today. I can answer for either P, Q individually whether it's true or false, depending on the situation. If I say today is Wednesday on a Wednesday, it will be true. But if I were to say it on a Tuesday, then it would be false. If I were to say we will have class today on a day in which we actually did have class, it would be true. And if I were to say it on another day, it would be false. But what about if I say the whole thing together? Today is Wednesday and we will have class today. When is that going to be true? And when is that going to be false? And the idea, of course, is that whether that's true or false, whether that whole compound and statement is true or false, completely depends on whether the individual statements are true or false. So, for example, suppose I said this to you on a day which was a Wednesday, and on a day in which we did have class. In that case, P, as an individual statement, today is Wednesday, would be true. And Q, the individual statement, we will have class today, would be true. And if I said to you, today is Wednesday and we will have class today, would you say, well, he's speaking truth? Or would you say, no, he's made a mistake somehow? You'd say, he's speaking truth. So what you see here is that if P is true and if Q is true, then P and Q, when you put them together, will still be true. Now we're going to put that in a chart, which we'll call a truth table. It looks like this. We've got 3 columns. The first column is P. The second column is for Q. The third column is for P and Q. And what the first row here is showing us that if P is true and Q is true, then P and Q will also be true. All right, we're going to fill out the other rows of this truth table. The second thing we want to think about is, suppose that I say this to you on a Wednesday, but we don't happen to have class. Suppose that I say this to you on a Wednesday during Christmas break, and I say, today is Wednesday and we will have class today. And because of that, the individual statement P, today is Wednesday, is true, but the individual statement Q, will have class today, happens to be false. Now, would you say, when I put the whole thing together, today is Wednesday and we'll have class today, would you say correct? Or would you say, no, you've got that wrong? You would say, no, you've got that wrong. It's false that both of them are true. Even though today is Wednesday, it's not true that today is Wednesday and we'll have class today. It's only true that today is Wednesday. So what this shows us is the next line of the truth table. You can see I filled in the second row there. Now I'm saying that if P happens to be true and Q happens to be false, then the whole thing, the third column, P and Q, will also be false. So if P and Q are both true, P and Q is true. If P is true and Q is false, P and Q is false. What happens if I say it to you on a day so that P is false but Q is true? I mean, suppose we also have classes on Monday, and I say this to you on a Monday. Then it would be true that we have class today, but it would be false that today was Wednesday. And so the whole statement would be still false. And so that's our third row of the truth table. If P is false, but Q is true, then P and Q will still be false. Because the only way the P and Q column can be true is if both of the individual statements are true as well. And then finally, of course, if I say this to you at a time in which neither of the individual statements is true, suppose I said this to you on a Thursday on a Saturday, so that it was not Wednesday and we didn't have class, that would make the whole statement definitely false. I mean, more false than ever. So the last row of the truth table says if the P and Q are both false, the final result, P and Q, the third column, will also be false. So this thing over here is on the right-hand side is called the completed truth table for AND. And what happens is, from here on out, this will basically be the definition for how an AND is evaluated. If we look at an AND statement, we'll treat it almost like a mathematical calculation. We'll just say it depends on what the individual statements are. If they're both true, the AND is true. If they're not both true, then the AND must be false. All right, we're going to do the same thing with each of the other 4 operators. So let's proceed. Second, P or Q. Remember that wedge means or. So we've got the same two sentences. Today is Wednesday. We will have class today. But this time I put them together with the word or. Today is Wednesday, or we'll have class today. Now, in this case, I'm not saying that both statements are true. I'm just saying that at least one of them is. So if it is Wednesday, I'm correct, whether or not we have class today. And if we have class today, I'm correct, whether or not it's Wednesday. I'm not saying that they both have to be correct. Both have to be true statements. I'm just saying at least one of them is. So if I say it on a Wednesday and we actually have class, certainly the whole thing is true. It's true because today is Wednesday, and it's also true because we'll have class today. It's sort of doubly true. So the first row of the truth table looks like this. If P is true and Q is true, then P or Q will also be true. On the other hand, if I say it on a Wednesday during Christmas break, even though we don't have class, it will still be true that today is Wednesday or we'll have class today, because I've said it to you on a Wednesday, even though we don't have class. And all it takes for the or to be true is for one of the two individual statements to be true. And that's what you can see in the next line of the truth table. If P is true but Q is false, still P or Q is true. That's different than the and. With the and, they have to both be true individually before the whole thing can be true. With the or, only one of them has to be true individually for the whole thing to be true, because or is a lot less stringent than and. Or is a lot more forgiving. So the third row is the same. If today is not Wednesday, but we do have class, it would still be true to make the or statement. The only way you can get a falsehood out of the or statement is if both of the original statements are false. If I say on a Saturday, look, today is Wednesday, or we'll have class today, you can say to me, no, that's false. It's false because on the one hand, today's not Wednesday, and on the other hand, also, today's not a day we have class. So that would make everything false. So the truth table for or looks like this. It has 3 truths down the third column and then a false at the end. In other words, the only way the or statement can be false is if both of the original ones are false. The and statement, the only way the and statement can be true is if both original ones are true. So they're sort of opposites of each other. The and, it's very easy to make false, but to make it true is sort of tricky. The or, it's very easy to make it true. You only need one of the 2 original statements to be true, but to make it false, it sort of takes an extreme amount of error. Okay, negation is the simplest of all. If I have a statement, but this is not a connective because it doesn't connect 2 statements. It's just an operator because it's only applying to one statement. Here I have a single statement, like today is Wednesday, and I simply say the opposite of it. So instead of saying today is Wednesday, I say something like today is not Wednesday. So the original statement, today is Wednesday, the underlined part is P. And the new statement is today is not Wednesday. And you can tell what happens here. If P happens to be true, that is, if today is Wednesday, then when I say today is not Wednesday, I'm wrong. So the whole thing will be false. So my truth table looks just like this. There's a P in the first column to show what the possibilities are of the original statements, and then there's a not P in the second column. We don't have 3 columns in the truth table here, but just 2. Last time we had 3 because we had 2 for the original statements and then 1 for the final statement. 2 for the individual P and Q, and 1 for the P and Q together. Here I only have a 1 underlying statement originally, just the P. So I just have 1 statement for my original statement, and then the last column, the second one, is for the not P. And what you see is that if P is true, not P is false. And of course, if P was false, if I said this on a Thursday, so that today is Wednesday was false, today is not Wednesday would actually end up being true. So whatever P is, not P is the opposite. That's pretty straightforward. If I hadn't told you that, you all would have known that's what happened. I just want to point something out interesting about the not, though. Notice that when I say a not P, it's actually true if the underlying statement is false. And it's false if the underlying statement is true. So this is, it's obvious, but it's interesting because the statement, the larger, more complex compound statement with the not in it actually has the opposite truth value of the original. That's important when we move to the next one, which is the trickiest of all. It's the P implies Q, or if P, then Q. Suppose I say today is Wednesday is P, and we will have class today is Q, and I tell you, if today is Wednesday, then we will have class today. All right, how does the truth of this if statement depend on the truth of the underlying P and Q individually? Here's what I want to point out to you. First of all, if I say, if today is Wednesday, then we'll have class today, have I said for sure that today is Wednesday? No, I haven't. So it might be that today is Wednesday, but it might not. I haven't said anything about that. I've just said if it's Wednesday. Secondly, it says if it's Wednesday, then we will have class today. Have I told you for sure that we will have class today? No, I've only told you that if today's Wednesday, we'll have class today. So I could be telling you the truth even if today wasn't Wednesday. And I could be telling you the truth even if we don't have class today. The only thing I'm guaranteeing is that if the first one's true, the second one has to be. And that's important as we look at this. So there's 4 cases again. The first one is suppose that both of P and Q as individual statements are true. Suppose that I say this to you on a day that actually is a Wednesday and a day in which we really do have class. So it's Wednesday, we have class, and I say to you, if today is Wednesday, then we'll have class today. What would you say about my statement? Would you say, you're right? Or would you say, no, that's wrong? Well, I think you'd say, yeah, you're right. It is true. Because guess what? Today was Wednesday, but you were correct. We did have class. So there's the first line of the truth table. If P and Q are both true, then P implies Q, or if P then Q, will also be true. The second line is also pretty straightforward. Suppose I say to you on a Wednesday in the summer, if today is Wednesday, then we'll have class today. And you think, well, you're right that today is, you didn't say today is Wednesday, but you think to yourself, well, today is Wednesday, but we don't have class today. And you said if today was Wednesday, we would have. So you got this wrong. In other words, if I were to say this, if today is Wednesday, then we'll have class today, and you know that today is Wednesday, the first part was true, but the second part wasn't true, you would say, you were wrong about that. You said that if it was Wednesday, we'd have class, and yet it's Wednesday and we don't have class. So that would be a statement. My statement would be false. My if statement would be false, even though today was Wednesday. And so that's the second line of the truth table. If P is true and Q is true, and I say if P then Q, then I'm speaking truth. But if P is true and Q is false, and I say if P then Q, then I've got something wrong. I'm either lying to you or mistaken, because I said if P was true, Q would be, and here P was true and Q wasn't. So that's that. Now, it's a little trickier to think about the third case. I'm going to go to the case right away where both of them are false. Suppose that I say this to you on a Saturday. Suppose I say suppose on this Saturday I would say to you, if today is Wednesday, then we'll have class today. But it's not Wednesday, and we don't have class. Would you say, ha, you're wrong? Well, I hope you wouldn't, because I wouldn't necessarily be wrong. I would say to you, I didn't say it was Wednesday. I just said that if today is Wednesday, we'll have class today. And since today's not Wednesday, we don't have to have class. I haven't guaranteed anything about what would happen if today wasn't Wednesday. So if I make this statement, if today's Wednesday, then we'll have class today, and today's not Wednesday, then I haven't lied. So we will consider this in modern logic. We'll consider this kind of statement to be true. Basically, anytime you have a P which is false and a Q which is false, and you put them together with an if-then, we'll consider it to be a true statement, because the statement has made no claim about what would happen if P is false. It's only claiming things about what would happen if P is true. So this is an accurate enough statement. It just doesn't say much. My kids used to watch Disney movies when they were young. And there's a place in the Disney version of Cinderella where the evil stepmother says to Cinderella, if you get all your chores done, you can go to the ball. And the 2 evil stepsisters say in horror to her, Mother, what are you saying? And she laughs evilly and says, I just said if. And they both laugh evilly with her and they say, yes, if. Because the point is, she didn't say Cinderella could go to the ball. She said, if you finish your chores, you can go to the ball. And the point is, as long as she doesn't finish her chores, the stepmother has been speaking the truth, even though she never gets to go. So if I say, if today is Wednesday, then we'll have class today, that's a perfectly true statement as long as today's not Wednesday. It only is a problem if today's is Wednesday and then we don't have class. Okay, finally, and this one sometimes throws people, suppose I say, if today is Wednesday, then we'll have class today, and I say it on a Monday, and it turns out we do have class on a Monday. Then was I lying? Well, the answer is, let me ask you this. Did I say anything about whether we would have class if it wasn't Wednesday? I didn't. I didn't guarantee anything about what would happen if it's not Wednesday. I didn't say we wouldn't have class any other time. I just said that if it's Wednesday, we will have class. So as long as I haven't told you what would happen on a non-Wednesday, it's fine if we have class on a non-Wednesday. So my statement as a whole is still considered true. And that means that third line looks like this. If P is false and Q is true, then P implies Q is still considered true. Now, we'll talk a lot more about this in class. But for now, let me just point out that the P implies Q, the if P then Q truth table, has coming down the last column, has true, false, true, true. In other words, it's nearly always true. If-then statements are easy to make true. There's only one case in which they go wrong and become false, and that's if the P statement is true but the Q is not. Because all they're claiming is that if the P statement is true, the Q must be true. And so the only way they can go wrong is when the P statement is true but the Q isn't. You'll need to memorize that, and you'll need to be comfortable with it. The last one, I'm just going to sort of run through quickly, and then we'll do a little bit more work on this later in class. This is the P if and only if Q. And so it's a little awkward to say, today is Wednesday, if and only if we'll have class today. And I'm just going to run right through these quickly. The basic idea of this is that if we have an if and only if between two statements, we mean that the two statements are always true together or false together. We mean that they're the same. Today is Wednesday, if and only if we'll have class today means if today's Wednesday, we'll have class, but also if today's not Wednesday, we won't have class. So if both statements happen to be true, then they are the same, and the whole thing is also true. But if the two statements are different, if the first statement is true and the second statement is false, then this whole statement is false. And if they're different the other way, so that the first statement is false and the second one is true, then the whole statement is still false. But if both of them are false, then they're same as each other again. If I say this on a Saturday, today's Wednesday, if and only if we'll have class today, then they're both false at the same time, and that makes the whole statement true. So I'll say more about this, but look at this truth table. Basically, the right-hand column, the P equivalent to Q column, the if and only if Q column, is true only when P and Q are the same as each other. And always when P and Q are the same as each other. So if P and Q are both true, it's true. If P and Q are both false, it's false. Usually this is used for statements where the two statements are sort of equivalent. Like I might say, today is Wednesday, if and only if tomorrow is Thursday. What I mean is, if today is Wednesday, tomorrow will be Thursday, but also if tomorrow's Thursday, today will be Wednesday. And if today's not Wednesday, tomorrow won't be Thursday. If tomorrow's not Thursday, today won't be Wednesday. They'll either be true together or they'll be false together. They're equivalent to one another. So here are our 5 truth tables. And this is what you need to know for the test, and it's one of the things you'll need to know probably for the next quiz. So I will simply ask you, write the 5 truth tables out and expect you to fill them all in. Now there's a lot of memory work here, but it's something you can learn, and we'll talk more about it in class and what you're expected to know. Okay, that's that. Thank you very much. Have a good week.